Hi guys, so 74th video of the Love Babbar 450 questions series. And before starting the video, I want to say that there are a few problems which I felt were difficult to solve, but they are not included in the list. I had found them in different places, and even n array trees are not included in the DSA sheet. So I'll be making videos on that also as I learn how to solve, because that's also quite tough. And in one of my interviews, like the internship interviews, I had got a question on n array tree. N array tree. So binary tree and binary search tree is kind of standard only, but those problems are also sometimes asked. It was asked for me, so you never know. It might be asked for you also. Tomorrow we will be starting with binary search trees. If you have not yet watched a single video, I put all the links in the description. Check out the playlist. Please share the channel with all your friends and subscribe. So let's get started with today's video. So today's first problem, sorry. This problem, which is construct a binary tree from a string with brackets. So, for example, if the string given to us is this, if the string given to us is suppose this, then this is equal to nothing but this kind of binary tree. How did we get this? We should keep a track of the brackets. So if the problem is this, that means this portion belongs to the left subtree and this portion belongs to the right subtree. Let us take one more example to understand. So for example, if the string is something like this, then how to make this a binary tree? It is going to be something like this, right? This full thing belongs to what? This full thing belongs to the left subtree. This is the right subtree. So the left subtree is this. So the left child of 2 is 4. So this is just a game of brackets. Just you have to play with the brackets. We can do the problem recursively only. But I don't know if my answer that I have written, the code that I have written, is it correct or not? I am not sure because there was no place to submit. But with all the test cases I took, it was passing only. I mean, I don't know if uh, like you can see the solution given by GFG also, but it was kind of difficult to understand at first what is happening exactly. But I have written this code. So the reason why I have used a string over here is because, see, for example, first of all, the input is itself a string, okay? So the input given to us is a string. We have to make it into number. We have to get the data value. Suppose 1 is there. This is 1 as a string. I have to make it into a number. So whatever is there inside the brackets, whichever number is there, that is a string, right? This is going to be a string. So I have to convert it into integer. So this is also one more important thing, one more important observation you have to make. If you are converting, if you are directly doing, it will give wrong answer because it is a string. So that is why I've used a string to integer conversion by taking a string over here. So basically between the brackets, the between opening and closing brackets, that will contain my number. It will contain the data. So I am storing it in a string, then I'm making a new node and then converting the string into integer and assigning the node value with the corresponding number. So after the node is made, after I have the node, I should check recursively on the left subtree and the right subtree. I have to assign node left something, node right something. So it all depends on the index values. So this is where I have some small confusion whether this code will pass all the test cases or not. So if anybody of you will be willing to test it with many cases and tell me, I have also done, but just to be more sure. And if the solution is wrong, please let me know so that I can correct. And if you already know the correct solution, much better than what is written in GFG. If you have written a cleaner code, please let us know in the comments. I was trying this and I don't know if it will pass all the cases. Just check it out. This index issue only I was having, like, will it pass all the cases? But I hope you understood what is going to be the method. It is just plain recursion only. And you will have to keep a track of the brackets, the opening and closing brackets. That's it. So please let me know if the solution is correct. If it is correct, maybe I'll then again make a video to explain with a complete example. But if I explain now and it turns out to be wrong, it will be a waste of time. So somebody, if you are willing to do, write in the comments that you will do the dry run. So with that, let us go to next problem, which is duplicate subtrees. So by reading the problem itself, you'll understand that you have to find out the duplicate subtrees. But what should you output? Before what should we output? First, we will see what are duplicate subtrees. I will give some small examples. So duplicate subtree means nothing but, like, if this is the tree, so if this is the tree, the duplicate subtree will be these two. This is one subtree, this is another subtree. If the tree was like this, then how many duplicate subtrees are there? See, 2, 4 is 1, 2, 4 is 1, and even 4, 4, right? But what should we output over here? How is the output going to be? So let us see what we should output. So output. If there are no duplicate subtrees, if there are no duplicate subtrees, we have to output -1. Otherwise, we have to print parent node. We have to print parent node of all duplicate subtrees. This is important because output format will decide how we are going to code, right? So we have to only print the parent node. That is what the problem also is saying. Print the nodes, and you have to print in ascending order also. So you have to print the root node of all the duplicate subtrees. Parent node, root node is same thing. And they've given definition also. Duplicate sub is a tree which has same structure. I think you all know what is duplicate, right? Nothing. So what is the code that I have written? And basically I have converted it into strings. We have already done that. I'll be showing it to you once again. So this is the function given to us. So I am making use of map over here because I will be converting the subtree into a string itself. Like tree serialization we had done, I think in a day before yesterday's video, in part 72, I think we had done a similar problem. We had done the problem, check if there is a duplicate subtree. Now we have to print all of them. So it's almost similar only. So we will be taking a vector to store all the parent nodes of the duplicate subtrees. And we'll take a bool function, we'll take a bool variable to find out if there is a duplicate subtree or not. So if after finding that there is no subtree, if it is false, if the value has not changed, see initially it is false. If the value has not changed, that means there is no duplicate subtree. So we will output -1. Otherwise, we will sort the answer and print it. But what is happening? What is this solve function? What is happening over here? So we are passing the map and the answer vector through reference so that the values keep getting appended. Again, over here, we are using the in-order traversal method. String serialization in-order traversal already discussed in part 72. We are basically making it into string. See, we are using this function toString. We are converting this integer into string and adding it to this string. We will check it in the map. If the occurrence of the string is 1, we will make f as true. We will increase the count over here. And because this is the first occurrence, we will push it into the map. Sorry, we'll push it into the answer vector. See, over here, this condition says that we have already found a particular value. We have already found that kind of string. If m of s is equal to 1, if the frequency of the string that we have found right now is already 1, that means we have found another one, right? We have found another string. Found another string means found another subtree because we have converted the subtree into string. So we are playing with string now. So if m of s is 1, that means the occurrence of this is already 1. So we have found out the parent node. We have found out the parent node and we are pushing that into the result vector and definitely change the flag variable to true. And then increase the frequency of that string. So if this was 0, if suppose m of s was 0, then it would become 1 over here. Then if we would have found the same string, again it would have, this condition would have been satisfied. What I'm trying to say is, see that part I actually explained in 72nd video, but I'll tell you once again. If there is a subtree like this, okay, if there is going to be a subtree like this is going to be converted into a string like this because it is in order traversal. So this string, these strings will be stored in map. If I find that the occurrence of this is already 1, if the occurrence of this string is already 1, if the occurrence of this string is already 1, then that means I've already found a string and I'm finding another one. So I've got a duplicate. So I will push the root node. I'll push that particular node because that particular node has become the parent node. And I have to print the parent nodes. So that is what is happening in this algorithm over here. So that was it. Binary tree is temporarily done. One question is on n array tree. I will do that when I'm doing n array tree. For now, let us move to binary search tree. So please share the channel with your friends, like the video, share it and subscribe, and take care, stay safe, stay tuned, and have a good night. Bye.